Hello everyone. Welcome and thank you for joining us today for our live webinar on current insights on battery regulation and what's ahead. So in today's rapidly evolving landscape, staying informed about battery regulation isn't just important, it's also essential. So from compliance challenges to upcoming sustainability standards, understanding the regulatory framework can make or break industry success. So we are thrilled to have an expert panel today. So they are ready to share their insights and answer your questions. So whether you are directly involved in compliance, sustainability, or innovation, this session will provide you with the latest knowledge and practical strategies. So before we jump into the context, let's get over some housekeeping items here. So to ensure a smooth session, all participants are muted except for the speakers to minimize any background noise. So the session is being recorded and will be shared with you afterwards, so you can revisit any key insights or at your convenience. We would love your feedback. So at the end, there will be a brief survey to help us improve future webinars. So feel free to drop any questions or comments in the chat. So we will address as many as possible during the Q&A, or we will follow up with you afterwards via email. So let's dive in. So now let's introduce our AP Engineering's esteemed speakers for today's webinar. So Impana is a dedicated regulatory specialist with extensive knowledge in battery regulations. And Swarna Kamal is a seasoned compliance specialist known for his expertise in ensuring organizations which meet stringent regulatory standards. So we are thrilled to have them share their insights today. So let's give them a warm welcome. Before going into the agenda, let's introduce our AP Engineering. So AP Engineering is a trusted provider of engineering, sourcing, IT, and compliance solutions for the automotive sector. Our expertise ranges from product development to regulatory compliance, ensuring our clients stay with competitive in a dynamic industry. So we also focus on IMDS, as you could see here, IMDS, REACH, ROHS, PFAS regulations with turnkey solutions of the software. So without further delay, I'm handing it over to Swarnakamal.
Thank you for the warm introduction, Pavitra. So I would like to welcome everybody who has joined this webinar, and I hope we will all have a great insight. So with the agenda today, we will be having introduction, the overview, objectives, and the timeline of the battery regulations. And we will see the battery life cycle impact, the roles of regulations in each stages, the global framework, overview of international regulations, the regulatory impact of who is affected by the battery regulations, collection and recycling. So the approaches, procedures, and recovery targets, the battery passports and its significance and in implementation, the compliance developments, challenges, and opportunities gives us the key insights into recent developments, compliance guidelines, and growth opportunities. We will also be saying the challenges and opportunities and the support which APA can do on those. So the conclusion will be the key takeaways. Without any delay, we can jump into it. So as an introduction, batteries are essential energy sources and pivotal in achieving the climate neutrality and fostering a circular economy. With the global demand for batteries projected to increase by at least 14% by 2030, they represent a rapidly growing market. Battery regulations ensure sustainability across entire life cycle from material sourcing to collection, recycling, and repurposing. In today's energy landscape, these regulations drive the development of a competitive and sustainable battery industry, supporting the clean energy transition and reducing dependence on fuel imports. Moving on to the overview, battery regulation refers to the management of battery systems to ensure they operate safely, efficiently, and effectively. As a key aspects, the charging control is to regulate the charging process to prevent overcharging, which can damage the battery or reduce its lifespan. The discharge management is to monitor the discharge rates and ensuring that the battery is not excessively depleted, which can also shorten its lifespan. The temperature management, which is the batteries are sensitive to temperature extremes. This regulation includes maintaining optimal operating temperature to ensure the performance and longevity. The battery management system is to monitor and control the performance of battery packs, balancing charge across the cells, the monitoring of health, and ensuring safety by preventing conditions like overheating or short circuits. The regulatory standards is with the industry standards and regulation They govern the battery safety, performance, and recycling. The effective battery regulation is crucial in applications ranging from consumer electronics to electrical vehicles and renewable energy storage systems. The objectives that the battery regulations has are safety assurance, ensuring the batteries operate without risk and overheating, fires, or explosion throughout effective monitoring and control system. The extended battery life, it's maximizing the lifespan of batteries by preventing overcharging, deep discharging, and other damaging conditions. The performance optimization is maintaining the optimal performance level by managing charge and discharge cycles, ensuring the batteries deliver consistent and reliable power. Efficiency improvement is enhancing the energy efficiency during the charging and discharging process, reducing the energy loss and operational cost. Balancing capacity balancing is ensuring uniform charge distribution among individual cells in a multi-cell battery pack to prevent imbalances that can lead to premature failures. Temperature control is monitoring and regulating the temperature to keep the batteries within their optimal operating range, which is very critical for their performance and safety. The compliance with standards is adhering to the industry regulations and standards to ensure safety, quality, reliability, and fostering consumer trust. The environmental responsibility is minimizing the waste and promoting the sustainable practices by extending battery life and encouraging proper recycling and disposal. User awareness is educating users on the best practices for charging and maintaining batteries, helping to prevent misuse and ensure safety operation. These objectives help create a balanced approach to the battery management that prioritizes safety, efficiency, and longevity. The roles of regulations in the battery cycle, as regulation play a very crucial role throughout the entire battery life cycle, starting from design, manufacturing, usage, and disposal. Let's see how they influence each phase. Design and development. The safety standard regulations set safety requirements for battery design, ensuring the batteries are built to withstand potential hazards like thermal runaway. The performance specification standards define performance metrics that batteries must meet, guiding manufacturers in a certain efficient, reliable product creation. Manufacturing. The quality control regulation ensures that the manufacturers adhere to quality standards which help maintain consistency and safety in the production process. Environmental compliance governs the use of hazardous materials and emissions during the manufacturing, which promotes eco-friendly practices. The transportation hazardous material regulations. So batteries, especially the lithium-ion batteries, are classified as hazardous materials during transportation. So these regulations dictate packaging, labeling, and transport method to prevent these accidents. In usage, the user guidelines may provide guidelines for safe usage, charging, and maintenance to prevent the misuse and extend the battery life too. Some regulations require BMS, that is the battery management system, to monitor the battery health and safety during operation. In recycling and disposal, the e-waste regulations, these laws govern the proper disposal and recycling of batteries to minimize the environmental impact and promote resource recovery. The extended producer responsibility EPR hold the manufacturers responsible for the end of life management of their products, encouraging sustainable practices. Incentives for R&D as research and innovation can provide incentives to develop safer, more efficient battery technologies, fostering innovation within the industry. Labeling and information disclosure as part of consumer protection, it requires the manufacturers to provide clear labeling and information about the battery performance, safety, recycling, empowering the consumers to make informed choices. By influencing these phases, the regulations ensure that the batteries are safe, efficient, and environmentally responsible throughout their life cycle. Battery regulation encompasses a variety of standards and guidelines that address safety, performance, environmental impact, and consumer protection. So let's see the key types of the battery regulation. The safety standards. The underwriter laboratories offer safety certification standard for the batteries, ensuring they meet safety criteria to prevent the hazards like fires and explosion. International Electrotechnical Commission develops international standards for battery safety and performance. The performance standards. Society of Automotive Engineers provides standards for automotive batteries, particularly for the electric and hybrid vehicles, focusing on the performance metrics like capacity and life cycle. The American National Standard Institute develops a performance standard for various battery types, ensuring they are reliable and efficient. The environmental regulations of the EU Battery Directive regulates the collection, recycling, and disposal of batteries within the European Union, which promotes sustainability and also minimizes the environmental impact. The Resource Conservation and Recovery Act of the US, it governs the management of hazardous waste, including certain types of batteries, ensuring they are safely disposed and recycled. The Transportation Regulation, the Department of Transportation set guidelines for the safe transportation of hazardous materials, including batteries, to prevent accidents during shipping. The International Air Transport Association establishes regulation for the air transport of lithium batteries, ensuring safety measures are followed. The Consumer Protection Regulations has the labeling requirements which mandate clear labeling on batteries to inform consumer about capacity, safety, instruction, and recycling options. Warranty and performance disclosure requires the manufacturers to provide warranties and disclose the performance data to protect the consumer interest. The extended producer responsibility of the battery recycling regulation requires the manufacturer to take responsibility of the entire life cycle, as we discussed already. The local and regional regulations have specific laws governing battery recycling and disposal and promoting proper practices, reducing environmental impact. Research and innovation standards, which has government incentives, they provide the financial incentives or grants for research into a safer and more efficient battery technology, encouraging innovation in the field. These regulations collectively ensure that the batteries are designed, manufactured, used, and disposed in ways that prioritize safety, efficiency, and environmental stability. The global regulation impacting batteries. So Mercury Containing and Rechargeable Battery Act of the US, which was effective from 1996, and US Lithium Battery Hazardous Material Regulation of the US of 2020, Battery Directive of EU from 2006, New Battery Regulation of EU from 2023, the Battery and Accumulators Regulation of 2008 of the United Kingdom from 2014, and WEEE Directive of the EU from 2012, and ROHS with the regions EU, China, United Kingdom, Korea, India, Japan, US, California, Singapore, Turkey, collectively with the EU reach, they all regulate in the battery life cycle. The global regulatory framework which we are about to see is for the European Union. The European Union battery regulation is a comprehensive framework aimed at ensuring safe, sustainable, and responsible use of battery within the European Union. It has several key components. The sustainability and circular economy is resource efficiency and recycling targets. The resource efficiency promotes the use of sustainable material in battery production and encouraging recycling to minimize the resource depletion. The recycling target, it establishes ambitious recycling targets for different battery types, including the portable automotive batteries, the industrial batteries, aiming for high recovery rates of critical materials like lithium, cobalt, and nickel. The performance and safety standards. The safety requirements mandate that the batteries meet specific standards to prevent hazards during their use or transport or even disposal. The performance criteria sets minimum performance requirements to ensure that the batteries are efficient and reliable throughout their lifespan. The labeling and information is eco-labeling and battery passports. The eco-labeling requires manufacturers to provide clear labeling on batteries regarding their environmental impact, including information on recycling content and proper disposal method. The battery passport, which is a digital battery passport that provide information on battery composition, performance, its recycling options, which is enhancing the transparency. Extended producer responsibility is the producers, the manufacturers, they are responsible for the end of life management of the batteries they make. which includes take-back schemes, recycling programs, ensuring proper waste is managed. Supply chain due diligence is responsible sourcing, which requires the company to demonstrate due diligence in their supply chains, particularly concerning the sourcing of raw materials, to ensure it is ethical and environmentally friendly practice. The harmonization across member states is the uniform regulation, which aims to create a consistent regulatory framework across the EU member states, simplifying compliance for manufacturers and ensuring a level playing field. The objectives as it is enhancing sustainability to reduce the environmental impact of batteries and promote a circular economy. Increasing recycling rates ensure that a significant percentage of batteries are recycled effectively, recovering valuable materials. Improving safety establishes the rigorous safety standards to protect the consumers and the environment. Promoting innovation, it encourages the research and development of advanced battery technologies that are safer and more sustainable. The consumer protection empower consumers with the information about the batteries they use, including the environmental impact and recycling options. The EU's battery regulation roadmap is when in 2023 it was kicked in, and in 2024 it aims for the collection and recycling to be the producer's responsibility, and by 2025 the battery waste management including the EPR and collection targets will be kicking in, and by 2026 battery passport will be made mandatory for EV, and by 2027 that public database for battery passport information will be launched, and by 2028 the minimum recycled content requirement for the portable batteries will be increased to 4%, and by 2029 51% collection target for the LMT battery is a deadline, and by 2030 73% collection target for portable batteries and 61% for LMT batteries will be made as applicable, and by 2031 it is the deadline for the commission to review and revise the regulation goals, taking it forward from 2032. The substance restrictions as part of EU is lead, mercury and cadmium. And lead has a threshold limit for 0.004% with and mercury at 0.0005% and cadmium at 0.00%, 2%, which it should not exceed its limit. And cobalt, antimony, flame retardants are made as additional considerations. The EU battery regulation requires that batteries should be labeled and CE marked to meet the safety, health and environmental protection standard. CE marking is a declaration by manufacturers that the battery complies with all applicable EU directives. It demonstrates compliance with essential safety, performance and environmental requirements. It is applicable to the batteries that fall under low voltage directives, which will be the household appliances like refrigerators, washing machines, and the lighting equipment like the lamps, LED systems, the power supply, electric cables, some batteries and chargers. All batteries must be CE marked starting August 18, 2024. The markings must be visible, legible, and intelligible. It should be either affixed to the battery. If not, it should be added to the packaging or accompanying documents. It should be accompanied by the certifying body's identification number along by the hazard pictograms or other hazard markings if necessary. Labeling. The labeling rules apply to all types of batteries, including the portable, automotive, industrial, and electric vehicle batteries. Proper labeling is very critical component for ensuring the compliance and enabling the sustainability. Batteries must be labeled with the manufacturer and importer's address, a batch of serial number, the battery category, the date of manufacture, the battery's weight and capacity, and any hazardous material present in the battery other than the mercury, cadmium, or lead. Any critical raw materials present in the battery at a concentration greater than 0.1% must should be labeled. Let's see how US governs the battery regulation. In the United States, significant legislation related to the batteries includes the Battery Act and the Bipartisan Infrastructure System. The Battery Act, officially known as the Battery Innovation Act, it aims to promote the research and development, commercialization. So the funding and research and development. It provides federal funding to support R&D in battery technologies, including improvements in efficiency, sustainability, and recycling. Innovation and competitiveness encourages the development of domestic supply chains for battery materials and components, reducing the reliance on foreign sources and enhancing US competitiveness in the global battery market. The partnership promotes the collaboration between federal agencies, research institutions, and private companies to advance battery technology and manufacturing. Focus on sustainable practices emphasizes the environmentally friendly practices in battery production, including the responsible sourcing of materials and end-of-life recycling. The bipartisan law, which was enacted in November 2021, includes provisions that directly impact battery development and deployment. The key aspects include investment in EV. It allocates significant funding for expanding the EV charging infrastructures across the country, facilitating the adoption of electric vehicles and associated battery technologies. The support for domestic manufacturing provides incentives for the construction and expansion of battery manufacturing facilities in the US, promoting local production of batteries and reducing the dependence on foreign supply chains. Research and development. It funds the research initiatives aimed at improving battery technologies, including the solid-state batteries, which is far considered safer and more efficient than the traditional lithium-ion batteries. Environmental consideration. It encourages the development of sustainable battery solutions and recycling programs to minimize the environmental impacts associated with the battery production and disposal. Overall impact is that both Battery Act and the Bipartisan Infrastructure Law represent a concerted effort by the US government to enhance the battery technology, support the transition to electric vehicle, and promote the sustainability in the battery life cycle. These initiatives aim to position the US as a leader in the battery innovation, manufacturing, addressing both economical and environmental challenges. The global regulatory framework as part of China has introduced new rules on recycling and disposals. China has implemented variety of key features like extended producer responsibility, in which the manufacturers are required to take responsibility in collecting, recycling, and proper disposal of the batteries they manufacture. This aims to encourage manufacturer design products that are easier to recycle. The collection and recycling targets. These regulations set specific target for collecting and recycling the used batteries, particularly the lithium-ion batteries used in electric vehicles and consumer electronics. This includes mandates for percentage of batteries that must be collected and recycled. Standardized recycling process. It establishes the guidelines and standard for safe and efficient recycling process, ensuring that the hazardous materials are handled properly and valuable resources are recovered efficiently. Registration and reporting is the battery producers and recyclers are required to register their operations and report on their collection and recycling activity. This enhances the accountability and transparency in the recycling system. The public awareness campaign. The initiatives to educate consumers about the proper disposal method and the importance of recycling batteries aims to increase the participation in the recycling programs. The penalty for non-compliances is the penalties for manufacturers and recyclers who fail to meet the collection and recycling targets or do not comply with the established regulations. The objective is in environmental protection to reduce the environmental impact of the battery waste and promote sustainable practices in battery production and disposal. Resource recovery is to enhance the recovery of valuable materials such as lithium, cobalt, nickel, and to reduce the need for virgin resource extraction. Pollution reduction is to minimize the pollution associated with the improper disposal of batteries, which can lead to soil and water contaminations. Support for EV market is to facilitate the growth of the electric vehicle market by ensuring that proper recycling systems are in place for used batteries. These regulations reflect China's commitment to environmental sustainability and resource conservation as part of its broader ecological civilization goals. The new rules aim to create a circular economy around the battery use, addressing the challenges posed by the rapid growth of electric vehicles and portable electronics. So before I inform my colleague Impana to take over the session, it's time for a quick poll.
Good day, everyone. I'm Impana. Thank you, Kamal, for providing us with the valuable insights into the basics of battery regulations. Well, I'll now take it forward and explain the remaining aspects. Let's see who is impacted by these battery regulations. The battery regulation impacts a wide range of stakeholders across the battery life cycle, from production to disposal. And this introduces stringent rules to improve sustainability, promote recycling, and thus ensure environmental and human safety. Let's break down the affected group. Firstly, it's manufacturers. Battery producers and assemblers are directly impacted, as they must comply with design, performance, and labeling requirements. They must disclose the environmental impact of production by providing carbon footprint declaration. They also must meet recycle target for recycled cobalt, lithium, nickel, and lead in battery production. And they must provide a digital product passport for tracking environmental and material data by 2026. Importers and distributors, they must verify CE marking and documentation by confirming label requirements such as recycling and material content information. They also must facilitate traceability through appropriate documentation and digital platforms. Equipment manufacturers that use batteries, we have EV manufacturers. EV manufacturers have to subject to stricter rules on sourcing sustainable and recycled material for batteries. Then we have consumer electronic manufacturers. They must ensure portable batteries are easily removable and replaceable by consumers by 2027. Battery recyclers and waste management companies. Recycling and waste management firms, face increased responsibility. They must achieve minimum recycling efficiency rates, that is 90% for cobalt, copper, and nickel by 2027. They must also comply with enhanced reporting on material recovery and treatment. They must support the collection of portable batteries with a target of 63% collection rate by 2027. Retailers and consumers. Retailers must ensure batteries sold comply with the regulations, including proper labeling and recyclability, whereas consumers are empowered with easier options for returning used batteries and receiving information about the environmental impact via labeling and digital passports. Yeah, let's see some of the approaches that are used for battery collections. We have three approaches. First, it's extended producer responsibility, collection channels, and targeted approaches. Let me take one by one. Extended producer responsibility, that is EPR. EPR is a policy approach where manufacturers are held accountable for the entire life cycle of the product, including post-consumer collection and recycling. Under EPR, manufacturers, they finance or they manage collection, transportation, and recycling program. They also encourage the design of batteries that are easier to recycle or contain less hazardous materials. They're also involved in take back activity, where producers must establish a system to collect used battery, often at no cost to consumers. By following this approach, it reduces waste, that is thus ensuring high cycling rates and proper waste handling, and this drives innovation in battery design. Secondly, collection channels. Channels are nothing but these are the logistical systems through which batteries are gathered from consumers and businesses for recycling or disposal. We have certain requirement under the collection channels, that is retail take back scheme. Retail serves as a collection hub, offering customers a convenient way to retain their used batteries. Thus, collection bins are placed in visible location within electronics or supermarkets so that they can dump the used batteries. Municipal collection points, local government established centralized collection sites at recycling centers, libraries, or public facilities so that these collection point cater to various battery types, including household, industrial, and vehicle batteries. Reverse logistics system. It's the process where used batteries are collected and transported back to the supply chain or disposal. And this leverages existing transportation network to minimize cost and thus ensuring safe handling, particularly for lithium ion and other hazardous batteries. As of now, EV manufacturers like Tesla and Nissan implement reverse logistics for spent batteries. Clear labeling. Battery must be visibly and consistently labeled to ensure proper sorting, recycling, and compliance with legal requirements. The labeling must include separate collection symbols, chemical marking, manufacturer details, recycling informations. Thirdly, the targeted approaches. Target approach for portable batteries. Let's know what is portable batteries. Portable batteries, they are small and they're commonly used batteries found in household devices such as button cells and rechargeable batteries for electronics. The target is to recover valuable materials like lithium, cobalt, and nickel to 73% by 2030. We have LMT batteries, that means light means of transport. These are the batteries used in light vehicles such as e-scooters, e-bikes, and overboards. Typically, these are lithium ion or other rechargeable types. This reflects the increasing use of LMT device and the need for responsible end-of-life management, which aims collection target of 61% by 2030. Then we have is industrial batteries. These are the batteries used in industrial equipment like backup power system and large scale energy storage. Currently, targets for industrial batteries are under review. Battery recycling procedure. Battery recycling involves a structured process to recover valuable materials, ensuring environmental safety and thus to reduce the waste. We have collection, first step, where it is done to gather used batteries from consumers, industries, or manufacturers and prevent improper disposal. Here, batteries are collected at designated recycling centers, retailer stores, and also it is needed to have specialized logistics to ensure safe transportation, especially for lithium-ion batteries, which can pose fire risk if damaged. Next is a sorting and classification, and the sorting and classification is done to separate batteries based on their chemistry. For example, lithium-ion, nickel, cadmium, and lead acid batteries for targeted recycling. And the sorting involves manual sorting and automated system. Manual sorting is used for smaller quantities wherein batteries are manually sorted, whereas for automated system, larger facilities use robotic systems to identify battery types by size, shape, and chemistry. At this stage, batteries are classified into categories for appropriate downstream processing. Next, we have mechanical treatment. This mechanical treatment is done to break down batteries into basic components for easier battery recovery, material recoveries. Here, batteries are crushed to separate casings, electrodes, and electrolytes. Mechanical methods such as sieving, magnetic separation, and gravity separation are used to isolate materials like plastic, metals, and active material. At this stage, metals and plastics are segregated for further chemical processing or reuse. Next, we have the chemical treatment. It is done to recover valuable metals through chemical process, and even this chemical treatment involves hydrometallurgy process and pyrometallurgy. Under hydrometallurgy, it uses chemical leaching to dissolve metals from the shredded materials. Here, the lithium and cobalt are covered using acid or solvents. With pyrometallurgy, high temperature smelting separates metals like lithium, cobalt, and copper. Then we have metal recovery. Extracted metals, lithium, cobalt, nickel, copper, and they are purified and they're stored in powder form. And then we have to ensure storage condition to prevent contamination and maintain material integrity for reuse. The last step is a reuse in battery manufacturing. The main purpose of this reuse is to close the loop and to reduce dependency on virgin material. At this stage, the recovered metals are integrated back into the battery production, forming new cathodes, anodes, and battery cells. Plastic and other metal components are repurposed for casing and other industrial uses. This benefits circular economy, reducing the carbon footprint and environmental impact of battery degradation. Thus, the minimum recycled content in new batteries must be 4% by 2030 and 12% by 2035 for portable batteries. This end-to-end recycling process, ensures a circular life cycle for batteries, significantly mitigating their environmental footprint. Let's get to know some of the targets for recovery of materials. The EU battery regulation, it has set some ambitious battery recovery targets to ensure sustainability and circularity. And these targets, they aim to maximize the recovery of critical raw material used in battery production while also minimizing the environmental impact. We can see current recovery rates. Cobalt, copper, nickel, and lead have to be recovered by 90%, whereas lithium by 50% by 31st December 2027. Cobalt, copper, nickel, and lead have to be recovered by 95%, lithium by 80% by 31st December 2031. These collection targets ensure that portable batteries are funneled back into the recycling system for material recovery. Next. Uh, Targets for recycling efficiency. These target define the percentage of batteries in materials in batteries that must be recovered during the recycling process, varying by battery type. For example, nickel cadmium batteries have to be recovered with a efficiency of 80%, lithium based batteries by 65%, and lead acid batteries by 75% efficiency. And these ambitions target, they align with EU goals for fostering a circular economy and achieving carbon neutrality by reducing the environmental impact of battery production and disposal. Battery passport. The battery passport is an initiative digital tool designed to enhance transparency, sustainability, and traceability across the entire life cycle of battery, particularly in sectors like EV and energy storage. It is introduced as a part of EU battery regulation, and this battery passport will become mandatory for all the LMT, that is light means transport, industrial, and electrical vehicle batteries with a capacity above 2 kilowatt starting on 18th Feb 2027. The battery passport is nothing but it's a digital twin of a physical battery containing essential data about its life cycle. This includes information on its production, chemical composition, carbon footprint, performance, and recycling potential. It will enable stakeholders from manufacturers to recyclers to access comprehensive data on batteries origin and sustainability credential. One of the main goals is to ensure transparency in sourcing of raw material. The passport will provide detailed insight into the battery's carbon footprint throughout its life cycle, from raw material extraction to end of life. This is a part of use efforts to reduce greenhouse gas emission and promote greener battery technologies. The passport will play a crucial role in supporting the circular economy by making it easier to track and recover valuable materials when a battery reaches the end of its life cycle. Let's see how it works. Each battery will be assigned a unique digital ID that is accessible through a secure platform. This ID will be linked to a database where all the relevant information is stored and updated throughout the life cycle. User can access this information via QR code and or a similar technology embedded in the battery itself. Digital twin, it is nothing but a battery passport creates a digital twin of battery that contains information about its life cycle, and it uses a blockchain technology to record and validate data about the battery's origin, processing, manufacturing, and recycling. And the information in a battery passport can be accessed through a QR code. Although the battery passport is part of EU's regulation, the concept is gaining international attention. China and United States are watching closely, especially as demand for electric vehicles grow. Other regions may adopt similar tools to ensure sustainability and traceability in global battery supply chain. The battery passport is a crucial step toward making the battery production more transparent and sustainable, ultimately supporting global efforts to reduce carbon emissions. These are some of the targeted areas of battery passport which focuses on transparency, compliance, market confidence, and circular economy. Let us see the final implication of battery passport. As explained, all the battery must have visible QR code, and thus this battery passport is applicable to all the batteries exceeding 2 kilowatt hour capacity, and the minimal percentage of battery materials should be recovered according to their nature, and it shall have a carbon print of the battery for the entire life cycle, and due diligence policies established to reduce the social and economic risk. Yeah, let's get into the timeline. Starting in 2024, all the batteries with capacity over 2 kilowatt hour, including LMT batteries, placed on the EU market must include a carbon footprint declaration. By 2026, this declaration will cover the entire life cycle of batteries from raw material extraction to disposal and must be published as a part of products digital battery passport. And this will provide a clear environmental ranking, and this will drive manufacturer to reduce emission across the life cycle of the products. By 2027, the battery passport becomes publicly accessible within the EU. By 2028, battery with a capacity below 2 kilowatt may also face requirements for carbon footprint. New technology advancement in battery recycling like second life use and material sourcing may lead to further updates in the carbon footprint assessment. This timeline represents a EU long-term strategy to reduce the carbon impact of batteries and promote a sustainable battery ecosystem and to align with environmental goals such as carbon neutrality by 2050. Let's get to the declaration requirement for the battery passport. The declaration requirement applies to the three main categories. We have EV battery, LMT batteries, and for rechargeable batteries. EV batteries, it covers rechargeable batteries designed for use in electrical vehicles, including hybrid and fully electrical cars. LMT batteries, these are designed for use in light electric vehicles like e-bikes, scooter, hoverboards. This applies to rechargeable LMT batteries with a capacity exceeding 2 kilowatt. Industrial batteries, it includes rechargeable batteries used in industrial applications such as backup power supply, energy systems, batteries in commercial or industrial machinery. And this also applies to industrial battery with capacity exceeding 2 kilowatt. It's time for a quick poll. Yeah, back again. Let's see the life cycle assessment methodology for battery. The life cycle assessment methodology, provides a structured approach to evaluate the environmental impact of batteries throughout the life cycle. We have two approaches. One is cutoff approach and the full cradle to grave approach. The cutoff approach mainly focuses on environmental impacts directly associated with the life cycle boundary, and it is often used for end of life process such as recycling and disposal. Whereas full cradle to grave approach, it considers the entire life cycle of product from extraction of raw materials, that is cradle, to the final disposal, that is recycling. End of life benefits like recovering lithium for reuse reduce the overall impact of the battery life cycle. Let's see the stages of battery life. Raw material extraction and processing. The LCA encompasses activities such as mining, refining, and processing of essential raw materials, including lithium, cobalt, nickel, and graphite. It evaluates emissions resulting from energy consumption and generation of material waste. Battery manufacturing. The LCA considers emissions generated during the production of battery cells, modules, and packs. This includes energy used during the assembly process and material losses that occur during production. Then distribution. The LCA assesses emissions associated with transporting batteries to end users. This includes emission from global shipping and last mile delivery. Use phase. The LCA accounts for emission related to battery charging as well as those from collection, transportation, recycling, or disposal of used batteries. It also incorporates credit for recovered batteries and their reuse in the life cycle. Thus, the LCA forms the foundation for regulatory requirements like carbon footprint declaration and digital battery passport mandated under the EU battery regulation. This ensures transparency and accountability in battery production and recycling process. Leslie have to comply. Each stakeholders, they have different responsibility. As a battery producer, producers have to register with their national authority to ensure that all stakeholders involved in the battery life cycle are identified and they're monitored under national and EU regulations. And they have to develop a compliance plan to establish a strategy to meet the regulation requirement effectively. And this serves as a clear roadmap to minimize risk of non-compliance and enhances operation efficiency. And they have to implement an effective collection system to fulfill obligations for collecting used batteries and achieving specified collection dates like 63% for portable batteries by 2027 and 51% for LMT batteries by 2028. They must also invest in responsible recycling to meet recycling efficiency target and maximize material recovery from batteries. They must also track and record data to ensure transparency and accountability in compliance. Distributors and retailers. Distributors and retailers must ensure they source batteries only from producers registered with the national authorities and compliant with EU requirement. Retailers must provide accurate information to consumer about battery usage, environmental impact, and recycling option. This improves, consumer awareness and encourages responsible battery use. And also, they must facilitate the collection of used batteries, ensuring their return to appropriate recycling and disposal system. Consumers. Consumers must prefer products with batteries that are designed for easy replacement and recycling, and they have to look for information on environmental impact such as carbon footprint, recycled metal content provided on the labels, and the digital product passport. This drives, demand for sustainable product and encourages manufacturers to align with eco-friendly practices. They must ensure that used or end of life batteries are disposed of in an environmentally responsible way, and thus this prevents environmental contamination. Consumer must stay educated about the environmental and safety aspects of battery use and disposal. This helps them make eco-conscious choices and actively participate in circular battery economy. Well, this collaborative effort will ensure that the benefit of the regulation influences the global battery production and consumption practices for sustainable battery future. Let's see some of the challenges in the battery regulations. Compliance complexity. You know, Effectively managing the implementation timeline and meeting diverse requirements such as CE marking, battery passport, and carbon footprint. This requires substantial coordination and specialized expertise, and thus this makes battery regulation a complex one. Increased cost. Implementing recycling process, redesigning products for replaceable batteries, and sourcing sustainable materials may increase production costs for manufacturers. Supply chain challenges. Ensuring ethical sourcing of critical raw materials like cobalt and lithium is difficult due to the global supply chain risk and the need for detailed due diligence. Technical adoption. Companies must redesign batteries and products to meet recyclability and durability requirements, which could lead to delays in product development. Logistical hurdles in recycling. Establishing efficient collection recycling system for used batteries complex, which is requiring significant infrastructure and logistical planning. Global harmonization issues. Companies operating globally may face challenges because it is difficult to align with EU regulations with differing standards in other markets. Let's get into some of the prospects or other opportunities in the battery regulations. Enhance sustainability, and this promotes a circular economy by mandating recycling and reuse of key material like cobalt, nickel, lithium, and reducing environmental impact. Innovation boosts. This encourages researches and development of new battery technologies such as solid state batteries that align with regulatory goals. And also this improves the consumer rights. The replaceability requirements for batteries in portable devices, they empower consumers to extend product life spans and by reducing electronic waste. Transparency and traceability. Digital battery passports improve traceability, offering insights into batteries life cycle, composition, and environmental impact. Competitive advantage. Early adopters of compliant technologies and practices, they can position themselves as the leaders in sustainability, thereby gaining an edge in global markets. Alignment with climate goals. This supports the EU ambitions to achieve climate neutrality by 2050, contributing to global efforts to reduce greenhouse emissions. Global influence. The regulation sets a precedent, potential shaping battery standard worldwide and driving a global shift towards sustainable practices. Yeah, well, I wanted to provide some context regarding the attached slide on the regulations. The slide, highlights how countries across the globe, not only US or EU, and even the many other countries are moving towards stricter battery regulations. And it is essential for us, to stay updated on these changes and prepare accordingly to meet evolving requirements. Next, yeah, next. Let's see how APA can support on this. APA can evaluate a company's existing practices, and they can identify gaps in compliance with new EU battery regulations, providing tailored recommendation for alignment. And also we can help create a compliance roadmap, advising on key regulatory milestones such as CE marking, carbon footprint disclosure, and battery passport requirements. And we also offer training programs to ensure client teams stay informed on compliance requirement, deadlines, and best practices, helping departments to understand the regulations impact. And also we conduct, let's say, assessment to measure and reduce the environmental impact of battery production, while also guiding companies on sourcing sustainable materials and meeting recycled content requirements by 2028. APA provides continuous monitoring of regulatory changes, offering updates and strategic guidance on adopting to any amendments in EU battery regulations. Yeah, let summarize the entire webinar. As countries work towards achieving net zero emissions, battery technology will be crucial in enabling renewable energy storage and electrification of transport system. Looking into the future, battery regulations, they're expected to evolve and become more stringent, with a greater focus on decarbonizing supply chain, battery technology innovation, and establishing global standards. And also the collaboration among governments and manufacturer NGOs, will be the key shaping regulatory frameworks that effectively address the complexities of battery production and use. In conclusion, battery regulation stands at a critical crossroads with the potential to significantly influence environmental sustainability, economic growth, and social responsibility. By tackling challenges throughout the battery life cycle and promoting innovation and ethical practices, these regulations can drive the global shift towards a cleaner, more sustainable energy future. By this, I'll conclude the battery regulation webinar, and I'll hand over it to Pavitra. Thank you.
Thank you both the speakers, Impana and Swarnakamal. As the speakers have shared their insights, so let us now open the floor for Q&A for next few minutes. So please submit your questions in the comment section, so our speakers will happy to answer them. Okay, as we conclude today's sessions, we would like to express our sincere thanks to each of you for joining us. We hope you found the webinar on battery regulations both informative and valuable. We truly appreciate your feedback. So as I mentioned earlier, please take a moment to complete the post-webinar survey, so as your insights which help us improve and shape future sessions. A recording of today's webinar will be shared with all the attendees for your reference. Should you have any further questions or wish to learn more about how APA can support you with product and chemical regulations, feel free to reach out us at compliance@apaengineering.com. Once again, thank you for your participation. We wish you a wonderful day ahead. Thank you, everyone. Thank you.